So 8.2, there's a couple definitions I want to go over. The rest is in basically just a review of the Calc 2, which is all posted. So for power series, there's a couple definitions we want to look at. One is analytic. So one of the definitions is analytic function. So an analytic functions and how that's defined has to do with basically the power series. So they call this definition 1. So a function f is said to be, or called, analytic at a specific value, so at x naught, if for x naught in some open interval, so I'll just put that down. So for x naught in an open interval a, b, they don't say it just like that, but that's okay. F can be expressed as a power series, essentially. F can be expressed as a power series with a positive radius of convergence. So the power series looks like this. So as n goes from 0 and approaching infinity, a sub n, x minus x sub n to the n. And they use the radius of convergence, they use rho is positive. So that's all they really are saying. So radius of convergence is positive, meaning it exists, like there is something that converges. Let me copy some familiar examples over. They're right here. Same as before, these are the power series cases. Forgot you gotta click on that. Okay, so, oops, I must have grabbed those little doohickeys there. So, there's some familiar examples that we can use. Let's see. Oh, a little discrepancy here I want to fix. Okay. That's what we get for these uncut versions. Almost no editing. Actually, I haven't done any editing this semester because it just takes so long to do. Okay, next thing is called the Cauchy product. This is a new thing too. So the Cauchy product, you probably know that name comes up a lot. So Cauchy is a lot of stuff. C-A-U-C-H-Y product. So the Cauchy product looks like this. So we'll look at the sum as well, but the product's what I'm getting at here. So we're going to let f of x equal the sum as n goes from 0 approaching infinity, a sub n, this is all the same, to the n, and g of x is the sum n is 0 infinity, b sub n, x minus x naught to the n. Okay, and the radius of convergence, it basically have to be for both, right? Or non-zero, so we'll just call it A and B. So both positive radius of convergence. Then the sum we know is pretty straightforward. F of x plus g of x, if you look at that, that's pretty simple. That's just the sum as n goes from 0 infinity. And then you just add up those coefficients, a sub n plus b sub n, and then the x minus x naught. Basically, every term that gets factored out because it's the same you can see here, I mean, gosh, this is the same in every term, and then it just gets factored out. So that and that's no big deal. The Cauchy product's not as obvious. That's this next. That's the next thing here. So the product of that is basically an infinite sum that happens. So you get the sum. Let's draw a better one than that. So you get the sum as n 0 to infinity of c sub n. Now this is the same, x minus x naught to the n, where c sub n ends up being that product. Looks like this. It's the sum. K goes from 0 to n. And then you have a sub k, and then b sub n minus k. So that'll take a little bit to calculate, but as you're reversing the order on this on b and then a goes in the same order as n. Okay, so there's a couple questions that ask to use the Cauchy product, so we'll have to take a look at that. Okay, then the rest of that chapter in section in 8.2 is just dealing with convergence and the power series and how to show it converges and using the ratio test to find the radius of convergence and the endpoint. So I have that all in the other material. The next video that I'll go on to that's new will be the 8.3, and that'll be on power series solutions to linear differential equations.